All right, Mr. Barr here. Today we're doing graphing using intercepts. That's a cool looking animal. All right. Learning goal, I can create and use linear equations and graphs to model real life situations. Line equations will help me understand the world around me and make predictions. You can graph anything. You can throw out a net and catch any graph, right? Of course, you could use the slope-intercept equation. That's an easier way to graph a line. But lines also come in a standard form. Those lines are also easy to graph. So we're going to work with graphs that are in standard form without a net. No net, 4x plus 8y equals 16. So we've already learned y equals mx plus b, y equals mx plus b, y equals, right? We've learned that already. And we know that this b value is the y-intercept. So when I see 2 right here, I know that's the y-intercept. We also might know that this guy over here is the x-intercept. So we're going to get this into our notes. The idea of intercepts, an x-intercept and a y-intercept. So here we go with our notes, graphing using intercepts. Let's start with your name. And our topic is graphing using intercepts. And before you can use intercepts, you need to understand what intercepts are. So here's a coordinate system. Here's a line. This point right here, this is the y-intercept. This point right there is the x-intercept. And as you can see, if you have those 2 points, you can draw the line just like that. So if I have the x-intercept and the y-intercept, the line is practically done for me. So how do I get the x and the y-intercepts? So there's an intercept, I can graph the line. If you know the intercepts, you can graph the line. All of these are intercepts. This guy right here, that's a y-intercept. X-intercept, x-intercept, not an intercept, y-intercept. If you plotted these, you would see that number 1, 2, 3, and 5 are all intercepts. What makes an intercept obvious is when it has a 0. It always has a 0 in it. So we're going to get this into our notes. Lines come in 2 main forms. So those are the 2 main forms of a line. And we'll write it with some numbers in it. This one you graph using Liam the leprechaun. This one we're going to graph using mini equations. So here we go. How do we get the intercepts out of this? So we're going to graph 3x plus 4y equals 12. To do this, I'm going to split it into two little equations. I split it into an x equation and a y equation. What's really going on is that I'm turning the y into a 0. If I turn this into a 0, I'm just left with the x. If I turn x into a 0, I'm just left with the y. Why am I doing this with the zeros? Because the zeros are where the intercepts are occurring. And if I solve this, I just found the two intercepts. So I break it into two little equations, and I solve each equation, and I have the intercepts. Now that I have the intercepts, I can graph this thing. The x-intercept is at 4. 1, 2, 3, 4. The y-intercept is at 3. And there is the line. I break it into two mini equations, and now I graph the equations, or the line, the intercepts. Okay, let's do this one. There's a picture of mini-me because these are like mini equations. Drawing. So I break it into two equations. I break it into 2x equals 8 and 4y equals 8. So x equals 4, y equals 2. X equals 4, y equals 2, and I draw the line between the 2 points. Let's do this one. I break it into two mini equations. 3x equals 9, negative 9y equals 9. X equals 3, y equals negative 1. X equals 3, y equals negative 1. I connect the dots with a line. I just graphed it. I break it into two mini equations. Negative x equals 6, dividing both sides by negative 1. So x equals negative 6. Negative 4y equals 6, dividing both sides by negative 4. Y equals negative 1.5. Negative 6 for the x. Negative 1.5 for the y. I connect the dots, and I get a line. Perfect. That's my lesson. All right, that was shorter than the last two. Hey, that's it. And if you have questions, you'll come and ask me questions. Thank you for watching.